Yeah, fine. Continue.
Hello, I'm Ria. I'm Carol. I'm Nikolai. I'm Shimon. And I would like to tell something about our schools. So that school is our school at Street Petista 25. Uh, it's in Krakow. We're in Poland, and I really like the school.
Good.
I would like to tell you what is the QRP exhibition. We are meeting in every Thursday, making planning like planning things to do for doing the things on QRP. QRP is the thing that every fifth grader needs to do in our school. That's what I mean. And I'm going to tell you about the topics we are focusing on. So our main topic is space. We are focusing on how everything was created, the Big Bang, and then the extinction of dinosaurs, and the possibility of life in space, and even if aliens are out there in space. And then about space technology, how we can go to Mars and everything. And then about black holes. And those are the topics we are focusing on.
Okay, cool.
So I have a question, dear sir. Could you say a few words about yourself?
Yes, so actually when I'll start the presentation, I'll first tell you from where I am, and then I think we will go ahead, because my first 3 slides are just me explaining who I am. So yeah, so we'll go through that. And you can hear me clearly, right?
Yes, I can hear you.
Yeah, cool. Yeah. Okay, so shall I begin?
Yes, you can begin.
Okay.
Yes.
Okay, so I will share the screen. So first of all, tell me, can you see the slides?
Yes.
And the second important question, can you see the red dot moving around? Because I need to point to things, right?
Yeah.
And now can you see it in full screen?
Yes.
Okay, so I will start the timer on my phone just to keep a track of, like, I should not extend the time. So I will start now. Dzień dobry, pani I pano, and that's the maximum Polish I know. So I will switch to English now. So hi everybody. I will speak about as I heard from one of you that you want to learn about the other topics as well. But this talk would basically be concerned about what gravity is and what are black holes. So if in between you have any questions, please ask. And if you feel shy enough, then you can tell your teacher the questions and she can mail me. I'm happy to answer in details. And the idea of this talk will be to understand, like, where is this dog or PS going into in this black hole thing. So I will begin now. So I am Syed Naqvi. I am a PhD student, and I am originally from India, which is over here. So you guys are here in Krakow over here. And I have been in Krakow for now 4 years. So I work at the Astronomical Observatory of the Jagiellonian University in Krakow in Poland. You know this. So this is our observatory. So currently I'm in India, but generally I give my talk from over here. So this is where my office is. And these are our telescopes with which we observe the stars and galaxies and everything. So who are we? We are a group of international PhD students, and we work on different topics, right? We work on astronomy, astrophysics, and cosmology. So what is astronomy? Astronomy is like, okay, if you see the sun, like, how far is the sun? Why is it giving us light, right? The astrophysics is that, okay, how did the sun came up to be in the first place? And then the study of cosmology involves, like, okay, so you have the sun and the planets, that is called a solar system. Obviously, the sun is one of the stars. There are, I don't know, millions of stars. Group of stars make a galaxy, and then there are a group of galaxies, right? So that study is what is cosmology about. So we are different PhD students, and we work in different areas. And I mean, the route to astronomical observatory is pretty clear. From Teatro Bragatella, you can take a bus and reach quickly. So it's in Krakow only. And so this is our astronomical observatory in Krakow. So we have different telescopes. Like telescopes are the objects which help you see the moon, the stars, and the galaxies and everything. So most of the time we work, and sometimes when there is a lot of snow, we make snowman. So this is the one which we made. And sometimes when we are tired, we sleep. So this is me sleeping, and one of my Polish friends, Franek, he took this photo over here. So generally we do research in this observatory. And what do we do in the observatory? We generally observe the stars and the galaxies and the planets, which I showed you, because those telescopes, they observe the things. And what do I do? Basically, I work on this topic called gravity. It's the basic fundamental thing. So I guess Aryan has a hand raised.
Yeah. So this question will be quick. How
Yeah,
strong are telescopes? So in like where you work, can the telescopes extend? They can see other galaxies. Can the telescopes?
Yeah, exactly. So this is a very good question. So you can see the size of the disk, right? Like it's
Yeah.
this much. So this is not that strong a telescope. This can only probe to some distance. But if you have a very large dish, like a huge big dish, so what you can do is you can collect more light. So since you can collect more light, you can look further into the universe. So these are small telescopes. Like these are smaller telescopes. You can look into the, let's say, the sun, the moon, and everything. But if you want to look at galaxies and far away objects, you would need bigger telescopes, which are obviously there on the on the other places around the world. Like
Yeah,
I guess
okay.
in South Africa and Argentina, there are like pretty big telescopes. So these telescopes are pretty small, but they are still powerful enough for you to observe astronomical objects like, I don't know, asteroid, meteoroids, or things like that. So is it clear?
Okay. Yeah. Thank you.
Yeah, cool. So I was telling over here that I study about gravity, like why do the things fall? So if I have this earphone and if I just drop it, so it fell to the ground, right? So why does this happen, and what role does gravity play in the study of these galaxies and everything? So this is the basic introduction. And what you will learn in this talk is, so why do things fall? And this is I don't know whether you have seen this cartoon. So this coyote, he used to every time fall down this huge, let's say a cliff or something. And why he used to fall down is because of gravity. And then we will try to understand this concept that if the mass of an object is more, does it imply more gravity? So let me ask over here, do you know what mass means? So
Yes.
yeah, you know, bit of idea, right? So like I have a mass, you have a mass, everything has a mass, and you have weight also. So that's the idea. And then I will just end the talk with this small, like we will just touch upon this, that when gravity is strong in a very tiny region. So okay, this is a bigger region, this is a smaller region. When all the mass is occupied in a very small region, then you come across a thing which is called a black hole. And this has been recently observed, and finally, I mean, it's a reality now. So now I will just tell you a bit about how history of science is done. But before that, I will tell you like how do you do science, right? It can be physics, chemistry, or mathematics. So there are two things in basically in all the sciences. Is one is the theory, and the other is the experiment. So theory is, suppose you on the left, you write some equations on the board, and if you, oh yeah, you have a question.
Yes. So gravity started to like galaxies started to form with gravity because there's like protons, neutrons, and some more that were
Yeah.
combined, that started to combine, and it's because of gravity, yes?
Yeah, it's because of gravity. So when you say protons and neutrons, so when they are combining due to a different force. That is actually electromagnetic force, which I will come into. But when, let's say, protons and neutrons, they combined and they form bigger objects, like as the objects go bigger, then gravity starts to play the role. So initially it was, as you said, protons and electrons, but that happens due to electromagnetic force. So right now I will speak about gravity. That is only happening due to the mass of an object. So we will come to this. So thank you for this good question. So do you have any other questions?
No.
Okay. So yeah, sure.
This is a bit of a silly question, but in the last picture, that Simpson Bart was going into a black hole. Was that a supermassive black hole?
No, this is actually this is a smaller black hole, which is called a stellar black hole. So I will tell you about this.
Okay.
Okay, so here I was trying to lay down this thing that the theory is something you just write down on pen and paper. And in order for that theory to be correct, you need to observe things, right? You need to do some experiments. So I don't know whether you have seen Tom and Jerry or not. So suppose Jerry throws a punch to Tom like this, and he grows and hits the wall. So if you follow this thing, which you will study later, is the Newton's laws of motion. So depending on how strong Jerry hits Tom, that far Tom will go, right? So you can write down the equations like how far Tom will fall. And then with observations, you can say that, okay, if I punch it little, it will just fall here. But if I punch it really strong, as he is doing, he will fall a greater distance, right? So this is like how theory and sort of experiment works. You write down something, but you have to prove it. And for that, you need to do observations and experiments. And now I will just go into the history of science a bit. So much ago, like not much ago, but long ago, how humans imagine the universe is because like this is like, I guess, around like very long behind in the human history, that people did not have telescopes or anything to look at, right? They used to just go out and see at the sky, and they say that, okay, here is a star, here is a planet. That time there was no air pollution. So this is just a very cartoon image that you are just looking at the stars, you see the trees, the sun, and you see the heavens and everything. So obviously this was long ago how things started to happen. But what people used to believe earlier, that Earth was the center of the solar system. So this is something which is called the geocentric model. So if you look carefully, they used to say long ago that Earth is at the center, and then there are these other planets, right? Mercury, Venus, Mars, Jupiter. So this was long ago that people used to think that Earth is the center of the solar system and everything else revolves around it. This was a general idea. But then it was Nicholas Copernicus, who actually studied from Jagiellonian University in Krakow. He said that no. Earth is not the center of the solar system. It is the sun which is the center of the solar system. And then obviously when he said that, then there were observations and experiment. And then it was finally established that, okay, sun is at the center of the solar system and Earth and all the planets are sort of revolving around it. So this is the correct model of the solar system, which we know is the heliocentric model. It just means that the sun is at the center. Then there are this planet is Mars, and then there are other planets, and then there is the Earth. So this was the correct model, as being sun as the center of the solar system. But the question is that how are these things holding together? So you have a question? Okay. Yeah, sure. Please ask.
Yes, so I forgot the question. Yes, if there is two things, and here's one thing, the gravity is stronger there or where?
Can you repeat again? Gravity is?
So if there is two things, and here's one thing, is the same size. When gravity is stronger or here?
So if you have two objects of the same masses, like they are not, one is not bigger than the other, then obviously the gravitational force will cancel. But if one is very massive, then the massive object will pull the smaller object closer. So more massive means more gravity.
Okay.
So Earth has the gravity, yes. Sun also has the gravity, because sun is so huge. That's why all the planets are revolving around the sun, and obviously not around the Earth, because Earth is very small.
Okay.
So this was obviously the geocentric model. And obviously, how do you know that sun is at the center of the solar system? Because you have these satellites, right? These are moving across the space, like these are man-made objects, and they observe that, okay, all the planets are revolving around the sun, right? So that's how this fact was established, that sun is at the center of the universe. Oh, not the universe, sorry, I have the solar system. And now the question was that, okay, if sun is at the center, what is holding everything together? And then Sir Isaac Newton, like the guy with this hairstyle, he came up with this concept that, so it's a famous story that he was sitting under a tree and an apple fell on his head. So he said that the force with which an apple is falling down on the earth is the same force which is responsible for the moon to revolve around the earth and the earth to revolve around the sun. So this was his sort of genius, that every particle attracts every other particle in this universe with a force, which is the Newton's gravity. But his brilliance was saying that right now, if I again drop this earphones I know that it will drop down, right? And also, if you are at the bottom of the earth, if you jump from here, you will not fall down, right? You will not fall away from the earth. You will fall towards the center of the earth. So this force with which this force which is responsible for the apple falling is the same responsible for the moon revolving around the sun, and the sun and the moon revolving around the earth, and the earth revolving around the sun. So this was the formula which Isaac Newton came up with. And remember that, is this formula correct? Yes, because we know that Earth takes 365 days to revolve around the sun. And how do you calculate it? You calculate with this formula. And using the Newton's gravity, so Newton came up with the theory. He said that, okay, everything attracts everything other and blah, blah, blah. And when Johannes Kepler, he used the Newton's theory, he was able to calculate the time it takes for the planets to revolve around the sun. So he used the Newton's gravity to explain the motions of the planet. Yeah, you have a question.
Yeah. How is it possible that planets is like by one occurrence one sun?
How is it that planet?
Planety ciągle jest tym samym co rok, bo co rok jest okrążenie Słońca.
So if planet is always in the same place every year, so how is it that they go around at the same time? Yes.
Yes.
Okay, so maybe I have misspelled it. I wanted to say that because the planets are revolving, so they are not still, because that's how we celebrate our happy birthday, right? Because the Earth is moving around the sun. It takes 365 days. So all the planets are revolving around the sun. Like this, like Saturn is revolving, Jupiter is revolving, Uranus is revolving. So because the sun is so massive, all the planets are revolving around the sun. So is this clear? Or maybe I missed it.
Yes.
Yeah. So yeah, Aryan.
So if the force is gravity, why won't the planets fall down? But they're circling. Why won't they fall down?
Yeah. So actually, if you look at the Newton's gravity, it says that because the sun and the earth are on a plane, right? So in a way, it is falling, but it is falling in a plane only. So the proper answer for this is actually given by sort of Einstein's gravity, which I won't go into. But you can imagine that all the planets are always in a plane. So it's not going inside. I mean, it might happen that if this is the sun and if this is the earth, and if you push it in this direction, then the earth will just go into the sun. But this is because how the solar system was formed initially, that they had some initial spin, or let's say initial push in this direction. So that's why they keep on revolving in this direction. And you can search for this fact that slowly and slowly this orbit is decreasing. So every 100 years, the earth is actually moving closer towards the sun. So it is actually falling towards the sun. But it happens in like every 1,000 years, few centimeters, the earth is getting closer and closer towards the sun. So first Mercury will go into the sun, and then our number would be there.
So if a planet went into the sun, would it affect Earth too because of the maybe?
Yeah, exactly. Let's say if this is the sun and if this is Mercury, so Mercury takes 88 days to revolve around the sun, right? But we know that slowly it is going closer and closer. So when Mercury will go inside the sun and sort of vanish, then the overall gravitational force which is acting will sort of change. Then Earth right now is taking 365 point something days to revolve around the sun. But when Mercury and let's say Venus also goes inside, it will take a different number of days to revolve around the sun. So that would change.
Okay.
So okay, is it clear?
Yeah.
And also one of you had earlier asked, so it's in a plane, but it is falling and the planets are revolving, right? So sorry if I said that they are still. They are not still, they are moving. And how they are moving? They are following Newton's gravitational laws, and it's an experimental fact now. So this is sort of correct. Okay, so 16 minutes already. So let me ask you a question very quickly. So suppose you are at a height, let's say you are on second or third floor, and in two of your hands, you have a feather and a bowling ball. You know a bowling ball, right? It's pretty heavy, right?
Yeah.
Everybody knows a bowling ball, right? So if you take the feather and the bowling ball and you are on the second floor or third floor and I am on the ground floor, so which will fall first? Can you take a guess? Yeah, please.
I think the bowling ball will fall down first because it's heavier.
Exactly. Yeah, and Aryan?
Yeah, the bowling ball will fall down first, and the feather would, I think, float, like
Hmm.
fly, not
And
exactly flying.
exactly. And for the others also, if I say that, because right now, because you are on the second floor and I'm on the ground floor and this is falling, let's say if I remove the air between the second floor and the ground floor, will it affect the result? So maybe or maybe not. So let's look at this video, which is like, I really like this video. So what they are doing in this video, I'll just tell you quickly. I hope there is no YouTube ads right now. So this is an actual experiment. So what they do is they take the feather and the bowling ball. I'm sorry. Yeah. So they take the feather and the bowling ball and they drop. So as you said that, okay, the bowling ball will fall first, right? So let me just look at this. So as you guys said correctly that it will fall, and as you guys were correct, this is happening. But this is happening when there is air between them, right? Because right now we have an atmosphere around us. So now what these guys will do is they will remove the air and they will create something called vacuum. When you create vacuum, there is nothing in between. So they will do exactly the same over here. So Aryan, you have a question?
No, that was just by mistake.
Okay, cool. So you saw it, right? So as you said
Yeah.
correctly, the feather will fall, blah blah blah. Now what they are doing is they are creating a chamber and they are removing all the air, and they will do the same experiment again. So they have created a chamber, they have removed all the air, the same objects are falling. So Uwaga, this is no magic trick happening. They are not showing you in slow motion. This is actually what will happen if you make two things fall, but in vacuum, or let's say in moon. So they will follow at the same. They will not follow. They will fall at the same time. Let me.
It's not in slow motion. No. It's not? No.
And this, so were you able to see that they are falling at the same time?
Yeah.
They were,
Yeah.
it's magic.
Yeah. So now it's magic, but also it's how gravity acts, because gravity affects all the objects in the same manner. So when the first moon, not first moon, when the first person, I think Niels Armstrong, he landed on the moon, the first experiment he did was, because remember on moon there is no atmosphere, right? So he took a feather and a hammer and he dropped it. They fell down at the same time, because objects appear to fall at different rates, not because of their mass is different, but because there is air resistance. A bowling ball, when you are right now, when in front of you, if you make it fall, it will feel less air resistance, but a feather will feel the air resistance. That's why it flows. If there is no air, if there is no vacuum, they will fall down at the same time. This is how gravity attracts every other object equally. So this is a strange thing, and you might say magic about gravity. Gravity as a force is a bit peculiar, and this is one thing. So keep that in mind, and I would have to move a bit quickly. So this is what I was telling you, and one of you had asked a good question, like electromagnetic and everything. So Aryan, you have a question?
No.
Okay, cool. So what is a force, right? This you might have not learned by it, but you have experienced this, right? So let's just revise for a little bit. You know that if this is a ball and if you and your friend tries to push it, it will just stay there, right? And if your friend applies a greater push, it will go towards the other side. The same push and pull, you know. And if you have to kick a, let's say, a football, you have to kick it with some force to go some distance, right? Now, what is happening is that these are some form of interactions. You might have seen lightning, right? Or you might use your mobile phones, right? So this kind of interaction is something which is different, right? this is what you have seen in your phones and let's say in your television. This is electricity and magnetism. This happens due to the charge of the particle, right? So again, that cartoon, that coyote, he's holding a magnet. You guys all know a magnet, right? Like a
Yeah.
magnet over here which attracts things. So if you spill some iron fillings, it will arrange in this pattern. Why this is happening is this, because this is the force due to the charge particles. So these are called electric and magnetic forces. This is in your earphones or in your mobile phones or in the headphones. But the force which I was speaking about, gravity, is due to the mass of the object, and this behaves weirdly when objects are falling in a vacuum. This you saw. Now you might have seen that if I have a small mobile phone, a small charger can sort of charge it, right? But let's say if I have if I have a Tesla car, I need a more heavier battery to charge that Tesla car. So here it means that higher the charge of the particles, higher is the electromagnetic force. So you can sort of think that if an object is more massive, will it have more gravitational pull? And this is what happens, right? Because Jupiter is the largest planet. I hope you know this. So because Jupiter is so large, gravitational force is more larger on Jupiter. And what will happen is, let's say you can somehow go on the sun, the Mercury, the Venus, and the moon. And if your weight on the Earth is 100, then if you are on the sun, obviously, first of all, if you are on the sun, you will sort of melt because everything is it's too hot over there. But if you are standing on the Earth, because the sun is so massive, you will weigh 2,000 times your weight. So you will actually be squished. And let's say if you go on let's say Phobos is the one of the moons of the Saturn, I guess. So if you stand on Phobos and if you weigh 100 let's say kilogram or something, you will weigh this much lighter. So you can actually jump like Superman. You can have like longer jumps and all. Let's say if you go onto the moon, you will weigh very less. So that's why if you saw the video of the moon landing, the astronauts were literally jumping, right? Because moon is less massive, so it has less gravitational pull. Now the idea is that, okay, if I ask you what is the most massive object in our solar system, can you tell me? Have a guess. In
It's
solar
the sun.
system, is the
The
sun,
sun?
right? So
Yeah.
everybody agrees, the other people, is the sun, right? The sun is the more massive, right? So this is in the solar system, it is very big. So if you compare the size of the sun and the size of the planets, like size wise, if you want to compare how massive the sun is, so you can see the sun it's pretty big. Then you have Jupiter, Saturn, and the other planets. And how big is the Earth? It's actually this much. So Earth is actually pretty small. But because Earth is small, that's why you have the gravity. That's why you have lesser gravity. If Earth was as massive as the sun, then we all would have been squished, and then it wouldn't matter whatever we do to get up. So if I will just give you some figures, so don't be intimidated by them. So the mass of the sun is this figure. So I guess you don't know this symbol, but this is 10 to the power 30. This means 10 followed by 30 zeros, right? That is very big. And the mass of the Earth is 10 followed by 24 zeros, like 24. So you can see that obviously mass of the Earth is much less than mass of the sun. So if you stand on the sun, you would actually be squished. I mean, apart from the fact that they will melt, but I'm just saying, more massive, you will be attracted more. Now, we know that the sun is actually a star, but what happens to a star at the later stages, right? Right now, the sun is there, but it is giving out energy, right? It is giving out light and everything. So what happens to a star at its end stages, like when the star is running out of its fuel? Yeah, Aryan?
It becomes a black hole.
Yeah, it becomes a black hole, but there is a little bit of let's say a caveat in this. So our sun is actually it's a very small young star. So what will happen? So here is our sun sort of. So our sun is actually a red giant, right? So when it will lose all its hydrogen and helium from the atmosphere, it will at max become a white dwarf. But there are objects or there are stars which are heavier than the sun, much heavier than the sun. These are called red supergiant. So for these objects which are much heavier than the sun, they actually explode, and as Aryan said, they will either settle down into a neutron stars. Neutron star are stars only made of neutrons, and or a black hole, as Aryan said. So if there is a very, very massive star, so only massive stars will end as black holes. So is this clear?
Yeah.
Yeah.
Okay, so now we come to the part like where why this dog is going inside and everything. So these black holes, these are actually objects where even light cannot escape. So this is very important, is that because you have these rockets which fly at a very high velocity, right? But the fastest object, or let's say the fastest speed in the universe, is light. So if you cannot travel faster than light, then you cannot escape something. So imagine you are on the earth and you are throwing a ball, right? You throw a ball with some force. And if the object is so massive that whatever you throw, it will not fall off the earth. So let me just rewind a bit. And I don't know whether you have heard about this, but this is a term called escape velocity. So you have seen these rockets, right? These rockets, when they have to go out from the earth, majority of the rocket has only fuel. Fuel is the petrol or the diesel. Why? Because it takes a lot amount of force to escape the Earth's gravity. So that's why you can see that this is the ship, but this much is the fuel. So you need to apply that much force when you are on the surface of the gravity to escape to escape the Earth's gravitational pull. So let's say if you have this ball and if you want to throw it such that it never returns to the Earth, you would have to throw it at 11.2 kilometers per second. So that's a lot of force, because otherwise whatever you will throw will fall down because it will be in the Earth's gravitational pull. Now, black holes are such object that even light cannot escape. So once you are at the surface of the black hole, no rocket will help you fly off. And there is a region called the event horizon, is that anything beyond the event horizon you cannot see. So first of all, do you know what a horizon is? You must have gone to the sea, right?
Yeah.
So you are at the beach, let's say Gadangs or Sopot. When you are at the beach, you can see that there is water, and then you can see ships coming from the other side, right? So that is one horizon where things can come to you. But a black hole has something. It has something different. It has an event horizon. Once you cross the event horizon, you cannot come back, because even light cannot escape, so no rocket can help you escape. So black holes are essentially objects which have so much stronger gravitational pull that nothing can escape a black hole. So that's why this Snoopy dog is going in. And Aryan had raised the question about supermassive black holes. So this black hole is a smaller black hole, but let's say when many black holes merge together, they form the supermassive black holes. So their gravity is also too big. But I will go it in the discussion section. So let me just go through this quickly because it's already 30 minutes. So now the peculiar question is that, okay, what is so strange about black holes, right? Why is light not able to escape, or why cannot any rocket take me away from a black hole? The idea is actually, this is a very basic idea, is this formula. So first of all, do you know about density? Have you heard density? Okay, so have you heard about mass and volume? Yeah, you know what, it's okay. If this is the phone, then it has some mass and it has some volume, right? So density is a concept. Let's say you all know Voda, right? Water. So water is less dense, right? You can put your hand in it. Water has less density. But let's say if I have this plate, I cannot put my hand through it, right? Because it is more dense. So what happens is that if you can do it in your calculator also, so if you take a mass of 10 and a volume of 10, you will get 1. I hope you know division, right? This is 10 divided by 10 is just give you 1. Let's say if I sort of decrease the volume, so I do 10 divided by 1, it is 10. If I keep on decreasing this guy, if I keep on decreasing the volume, you will see that the density will increase. So if I take a mass of, let's say 10 kilogram, and if I compress it in a very, very, very small region, then you will get a really big number. So what it is saying that a huge amount of mass is sort of concentrated in a very small region. So the density of the object goes higher. So right now, Earth is a planet, but if you shrink Earth to the size of a marble, of 12 centimeter marble, then Earth will also become a black hole. And then obviously we all will go into the black hole. But you should not go near a black hole, because what will happen is something which is called spaghettification. You will get stretched into. Why? Because the gravitational pull is very, very, very strong. And to understand the gravitational pull, to understand more fundamentals in black hole, you would need Einstein's theory of gravity, which sort of I study. But now there is one interesting question. If I'm saying that if there is a black hole and if everything goes inside, if light cannot escape, then how do you see a black hole, right? If it is not emitting anything, how do you see it? So this is just the second last slide, is that if nothing escapes, then how do we see the black hole? Now what happens is that if a black hole is alone, obviously you won't see. But if there is a sort of a star, or let's say a sun or something, it will slowly accrete matter. Accretion is like the particles go inside the black hole. And once they go inside the black hole, friction happens. And due to that friction, they emit radiation. And that's how you indirectly see a black hole. If there is a single black hole, you won't see it because nothing escapes it, right? But if there is a star, or let's say dust particles, these go inside the black hole and they emit the radiation. And so I will end over here. So dziękuję za uwagę. So I will not show this one video which we wanted to show, because if we have time after the discussion, we can have it. So I will pause it. Right now it's almost 35 minutes, so I should have made it more shorter. So right now I will just end by saying is that the important thing is to never stop questioning. So if you have any questions, please ask. And now let's go ahead. Yeah, please ask. Yeah, you can.
I want to know actually what happens with the thing. For example, I don't know. For example, a rocket, when there is a black hole, what happens inside?
So you are saying that, yeah, you are saying that if this is a black hole and if a rocket is moving around, what happens inside the rocket, right?
Inside the black hole.
Yes. So if you are near the black hole, then the rocket and everything will just get squeezed into. So your whole body will sort of like stretch in one direction, squeeze in other direction. So will be your rocket. It will just stretch and squeeze, and we will sort of not survive that. Yeah, please ask.
So I have a question. Is there something called anti-gravity?
This people are looking into, but unfortunately till now we haven't found any evidence of anti-gravity, because the idea is that, okay, if you have matter, so mass attracts mass, what if there is some antimatter which will repel things, right? But we haven't observed such things yet, so they are not there.
Ria?
So what if I get stuck inside a black hole?
So if you get stuck inside the black hole, then the problem is that, as I said over here, right? If you focus on this last number, because the density is so huge. Remember that remember that example that right now if you are 50 kg or something on the surface of the sun, you would be squished, right? Because the gravity is so strong. At the black hole, the gravity is much, much, much more strong. So once you will go inside a black hole, you will actually be squished. And here I wanted to make a distinction, is that the black hole which I am talking about are stellar black holes. What do I mean by that? Is that when the star bigger than the sun, when that explodes, that will form a black hole. And once you are near the black hole, you will get stretched and squeezed. But when one word Aryan was using, he was saying supermassive black holes. So at the center of the galaxies, there are these huge, big black holes, which are like million times the mass of the sun. There, what will happen is that you will cross the event horizon without any stretching and squeezing. But at the center of the black hole, you will actually be squished because the density would be infinite over there. So is that clear? Yeah.
Aryan?
So I have two questions. So I was reading a book and I came up across this fact that in the center of a black hole, there's this thing called the singularity. And is it true that there's no time, like a place where there's no time and matter is compressed down to an infinity? What is it like about?
So it's about, so this is where I did not go into because this is a bit higher concept. So you can look at this guy, right? Einstein came up with, so Newton, Sir Isaac Newton, he had his theory, which is called the Newton's theory of gravitation. Sir Einstein, or not Sir Einstein, Albert Einstein, he also came up with his theory of gravity, which is called the general relativity. So in that, what it says is that gravity is nothing but a bending of, you all have seen a rubber sheet, right? Rubber sheet, you know, let's say rubber sheet. And if I put a massive object on that, the rubber sheet will bend. And if I throw
Yeah.
some marbles around it, the marbles will go in the circle and then come to the blank. So according to Einstein, gravity is not a force, but a bending of this rubber sheet. But this rubber sheet is called space-time. Space is obviously like the three-dimensional space, like the X direction, the Y, and the Z direction, where you can move and go around. And then time is the basically, I don't have a watch, but you know what time is, right? So
Yeah.
according to Einstein, gravity is nothing but a bending of the space-time. And at the center of the black hole, what happens is that because gravity is so strong that the space-time sort of ends. So your theory breaks. Since your theory breaks, you cannot say anything more about it. You can just say that, okay, there is, as the word which you used is singularity. So singularity is the point at the center of the black hole where the gravity is infinite. And there your theory breaks down. So we do not actually know what happens to the singularity. And just answering to Ria's question over there, like if you enter a black hole, because you cannot escape, you will always go towards the singular point because you just cannot escape.
And I have another question. What are primordial black holes?
So these black holes which I was talking about are stellar black holes, right? Okay, if there is a star, it keeps on going bigger. If it is much, much bigger than the sun, then it will end as a black hole. So these are called stellar black holes. But at the very beginning of the universe, when the Big Bang happened, there are these theories that very small microscopic black holes might have formed at the very beginning of the universe. And slowly as the universe progressed, these black holes, like they ate other stuff and they grew big. So some of the black holes which we observe in the galaxies might be primordial black holes, which are not happening due to the stars getting exploded and everything, but they were there from the beginning of the universe.
Okay.
Okay, and you have a question?
Yes. Is there can we see a point, for example, a white point inside a black hole, or only black? We can see nothing.
We can actually see nothing. So right now, this first of all, this image is just a cartoon, right? So that's what I was saying, that if you have just a black hole, you will not see anything because there is no light coming out of it, right? But if there is a star or dust particles around a black hole, these particles will start to go inside the black hole, right? Because remember, black hole has like much more gravity. So once these particles start to go inside, once they will go inside, they will emit out something called radiation. Radiation is like, so right now you can see me, right? This is the electromagnetic radiation. So similarly, they will also emit this radiation, and you will see the black holes indirectly. And just one more thing I would want to add is that if imagine you have one black hole over here and the other black hole over here, if they are revolving around each other, so they will come close and they will merge. Once they come close and they will merge, they actually release something which are called gravitational waves. So these are actually detected. So the last to last year Nobel Prize was given. So black holes were detected like this. So either you see them indirectly via these particles going in, or you see them via the gravitational waves. Gravitational waves are sort of ripples in the space-time itself. So you can see them via that also. Yeah, you have a question?
Can I?
Yeah, sure. Please go ahead.
So I have a question. Is it true if more things go to a black hole, it gets bigger?
Exactly. So this is so let me just give a context. So we know that sun is at the center of the solar system, right? Okay. Then because sun is just one of the stars, so there are many stars, right? I think 10 to the power 11 stars make up a galaxy. You all know what a galaxy is, right? Like a group of stars, right? So at the center of these galaxies, what is thought to be are supermassive black holes. So what Aryan had said and what you are saying, that at the center of the galaxies, there are these very, very million times massive, supermassive black holes, which keep on taking matter from the surrounding, and they just keep on growing bigger and bigger. Because obviously, if matter is going into the black hole, something has to change, right? That is the volume of the black hole that goes on increasing. So if there is a little black hole, if it absorbs the sun, it will slowly get bigger. If it absorbs another sun, it will slowly get bigger. Yeah, please ask.
Is black holes doing some noises?
Can you repeat? Is black hole?
Is black holes doing some noises? And can you hear it from like 1,000 kilometers or something like that?
So basically, do black holes make noises? And can you hear it from like 1,000,000 kilometers or 1,000?
So the so the only way to, first of all, because can you listen to, no, actually you cannot, because these black holes, because light also cannot emit a black hole, so sound anyways cannot, right? Because sound is like, because I'm speaking, so it has some velocity, right? So I say hello, so the voice goes into the microphone, then to you, then to you. So this has some particular velocity, right? The air molecules have some particular velocity. The fastest velocity a particle can have is the velocity of light. Now, because light also cannot escape a black hole, so if I'm at the black hole and if I'm shouting help, uaga or something, that will also not reach you, because everything goes inside the black hole. So it will not reach anyone. Yeah.
So I have two questions. First, there's been like a new theory going around about white holes, which are basically the opposite of black holes. So what is white holes actually?
So so I would just remind everybody that, remember that there is theory and experiments, right? So theoretically, you can write down the Einstein's equations. You say that, okay, there is a black hole. And then once you observe the black hole, you say that, okay, black hole exists. These are not just random things on a piece of paper. Similarly, there is a theory which is, similarly in that theory, in Einstein's theory, you have something called a white hole. So if a black hole is taking into all the matter inside, maybe there is an object which is throwing out matter from itself. So that is a white hole, but this is just in theory. This has not been found yet. So in theory, it is there. Like a white hole might be a, I don't know, a window to other universe which is throwing out matter, but this is sort of just the theory part. So there are no experimental proofs of it yet. I mean, in future we might have, we don't know.
Yeah. Okay, and like, so will there be a black hole that will eat everything, eat the whole universe in the distant future?
Could. Yeah. So as far as I know, there are like millions of galaxies, right? And every galaxy has a black hole at the center of the universe. And because so this is another concept which you should see, is that if I have a galaxy, it will have mass, right? If it has mass, it has gravitational pull. So one galaxy is attracting the other galaxy. So right now, Andromeda and our Milky Way galaxy are almost on a collision. It will happen in million years or something, but they are actually coming together. So when they are coming together, each galaxy has this supermassive black hole at the center. So they will also merge together and form a bigger black hole.
Oh, so Sagittarius A.
Yeah, so it might happen that all the galaxies will come together, and in the end there will only be a black hole, because everything would go inside a black hole. But that will happen in a million to million years. The time scale is too much.
Okay.
Ria, you have a question?
Yeah, so I'm just curious.
Yeah,
why
sure.
are black holes called black holes?
Why do?
Why are black holes called black holes?
So this name was actually given in Newton's gravity, when Newton came up with his gravity. The basic idea was simple, that if I'm standing on the earth and if I want to throw something from the earth such that it never returns to the earth, I need to throw it with some velocity, right? So people used to think that there might be such an object that no matter how much force you apply, nothing will escape that thing, right? And that they sort of named it as black hole. Black hole means that you cannot sort of see anything. Why? Because everything is going inside the black hole, so you cannot see. But this was just a nomenclature long back, and now people just caught on with it. I think it was John Mitchell who came up with this name, but his idea was that, okay, there might be some strange object if you are on and nothing can escape it. So what to make it? It's just because nothing can escape it, so it would be a black, and because everything would just get sucked into this thing, so they named it hole. So black hole.
Yeah, that's it.
That's it. So,
Thank you so much.
Yeah,
Okay, so
thank you
do
so
you,
much.
so do you guys have a little time, because I wanted to end with this video, because this is just showing how observations are. So it's just showing how you go into the galaxies and everything and you see a black hole. So do you have time, or I'm fine with ending it now?
I personally do because I'm not in school.
Okay. And what about others and the teacher?
Yes, we've got time.
Yeah, sure. Okay, so I'll just show you this video, and I can send it to you also. So what they are trying to do is, so this is a bit long video, but what they are trying to do is, you know that we are in the Milky Way, right? So we are in the Milky Way. What they are trying to show is, they are trying to show another galaxy, and you are going deep at the center of the galaxy. So once you go at the center of the galaxy, you would see a supermassive black hole, but you cannot see it. So how do you infer it? So if you remember, the sun and the planets are revolving around something, right? So that is how they infer. So I'll just show you.
Oh, this is Sagittarius A.
So just remember, a galaxy has 10 to the power 11 stars, right? So it will take a time to zoom into the center. And how are you looking into this? You have the Hubble telescope, which is there orbiting the Earth. So that is looking into the center of this galaxy called Sagittarius A star. So now I just want to say is that you can see these white objects, right? So these are the stars, but you can see that they are orbiting something, but that is not emitting light. So you just need to focus at the center where the star is just going like this. I will point it also over here. So this is the orbit of the star they are trying to show. Like they're just showing in slow motion how it is.
Wow.
So this is the black hole. Now I would just want to end by saying this, that because very early, and remember that this, when the star is moving around this object, you can do the calculations with Newtonian gravity, right? Remember, the sun is between and all the planets are going around. So you can do the calculations. So when obviously Einstein came up and his theory came up, so these black holes were just thought to be abstract objects. Everybody was like, these are just objects, these can't exist. But when the telescopes and when the experiments came up in the picture, so finally now you have experimental proof that, okay, there is a black hole. These are not just theoretical things, right? These are experimental facts. And that's why the Nobel Prize was given for them. Yeah, you have a question.
Is it true that every planet need to have, sorry, is it true that every star needs to have one planet?
Sorry, every star will?
Is it true that the one star needs to have one planet?
Needs to have one planet.
Please.
No. This is not necessary. This is not, because what happens, like when the stars are actually forming. So let me show you. So actually, I haven't shown you in detail. So there is something which is called a stellar nebula, right? These are just dust particles which are just moving in space. So when the dust particles come together, when they come close together, they become more massive. When they become more massive, they attract other objects, right? And it might happen that some of those, when the matter is coming together, the first two atoms would be hydrogen and helium. So they will form a star. And when they form a star, if there is some dust around the star, that will form a planet. But it can also happen that just a star forms and there are no planets around. But mostly it is found that because when the star is being formed, there are some dust particles left around. So over a period of time, these dust particles accumulate, they form the planets. The gaseous particle accumulates, they form the stars. So first the stars form, like the hydrogen and the helium. And then there are these dust particles, the other elements. And how did these other elements came? They came because of the supernova. Because somewhere a supernova might have happened. And when a supernova happens, all the different kinds of, let's say, elements are released. Carbon, nitrogen, iron, and all the gold and everything. So that gets released. So that is what forms the planets. Gases are forming the stars, but planets might be formed like this.
No.
Mhm. Okay, so Carlos still is into the question, and his question is that he understands the transformation, but the question is like this: if there is a star, are there or should there be a planet that is somewhere near the star that belongs to the star? Yes.
Oh, like
Yeah, so-
orbiting the star.
Yeah. So these systems are what are called binaries, right? And once these telescopes which are set up, so right now the video which you were seeing is the galaxies, black holes. So this is recorded by the Hubble telescope. But Hubble telescope is not only to observe the black holes and everything. These also search for something called the exoplanets, like small planets revolving around the star. And the idea is to look into the signatures of life, water, or anything. So there are these exoplanets, which I think there are many exoplanets, and the observatories are looking and collecting data from it to see whether life can survive in an exoplanet or not. So there might be just a star and one single planet revolving around it, or a star with just two planets revolving around it. So these things are there in the universe. Is it clear?
Okay,
Yeah.
yes.
Ah.
Thank you.
Thank you very much.
Thank you very much
Okay.
for your presentation and everything that about
Yeah, it was really interesting.
Okay, thank you. If you have any questions, you can just like write to your teacher. She can mail me, or yeah, I'm happy to answer. And also, just one thing, because this is obviously online, but generally, what used to happen in our observatory in Krakow is that we used to do these tours. Like it's generally the English speaking people who are in Krakow. So we used to take them around a tour of the observatory, give a talk, and obviously, if the sky is clear, we used to see the moon or the nebulas and everything. So if in future, if it is there, you guys can just come at the astronomical observatory. You can have a look at the telescopes. We can again give a talk on, I don't know, black holes or exoplanets, because there are many amazing topics around there. So yeah, you're welcome.
Thank you very much for
Thank you.
and for the presentation. We're going to use our interview or our QIP exhibition, and hopefully some of the facts are going to be placed on Aryan's presentation, because he actually is very much interested in
Black holes.
black holes. That's right. So one more time, thank you very much.
Thank you.
Okay.
Just from our presentation.
Yes, thank you very much.
Thank you very
Okay.
much.
Thank you so much, man. Okay. Enjoy. If you have any questions, please feel free to ask. I mean, you can
Thanks. Thank you.
mail your teacher and I can get. Okay. Thank
Thank
you.
you.
Bye, man.
Bye.
Bye.
Bye. Ciao. Do widzenia. Bye.